The
Yo.
bowl. And this happened last year, say?
Yeah, man. No, I'm telling about the earthquake about last year when I stone them bowl of them come down.
And one of them here, you say? One of them big one,
One of them big one, man, they made up bust it up. I think I bust the tractor, bust up one and chop over one over a gully. The earthquake they happened in a day. I think I one day cause with that work and we end up going home after.
So that's 2025.
Yeah,
This
2025.
this something.
Yeah, the one that cause you can't forget the one in a day. I think early in the year between January.
That means that yes, sir, is definitely prone to rockfall, man.
You know, so,
Yeah, man. But me never know, say it dropped down again in 2025.
Yeah, drop down in 2025, man. There is some big one. Truck pull out, come up in the road. I tractor shoot it.
Okay. When them thing that I'm still, if I make a report of it, still, yeah? Make a report of it.
Alright.
As you heard this gentleman just state, this location experienced a repeat rockfall event. It occurred in 2025 after an earthquake. Now, this location, if you remember in the media in 2023, would have been a site of rockfall. I have the clip here where I highlight the said rockfall back in 2023. And the gentleman is there in the top left in the July 2026 capture. I also have a capture of the area of the slope that would have had the rockfall, and this is at the bottom of this given screen. Now at this time I'm giving you a cross section of the slope that this rockfall site is located. Now generally the color system is as follows. The yellow is the coastal geology, which includes carbonates and volcanics. The blue is the alluvium, and the purple is the karstic carbonate, which can also be somewhat impure or can be weathered into an orange-brown clay texture. Now note the dashed lines. The dashed lines are the inferred faults. In terms of the direction of the dashed lines, we can see that there is a southeast, northwest orientation and a west-southwest, east-northeast orientation. Essentially, these two dashed lines in terms of the fault representation are as follows. The Wagwater, which is the southeast-northwest, and the Planting Gun, which is the west-southwest, east-northeast. Do you remember this photo? This image is at another location in the Bull Bay area. And if you remember in the video, I would have outlined the general orientation of the image in terms of the faults themselves. Essentially, that picture represents what it is that's also transpiring at this cross section of the slope. So in connecting the dots, it is highly likely that the spot that the rockfall is actually occurring is the location that the Wagwater and the Planting Gun faults intersect. Not only that, those said two earthquake systems are also active. So in so doing, as they move, they contribute to weakening of the overall inherent strength of the rocks. They also can contribute towards the widening of joints. And in so doing, it basically is a case where the slope becomes more so susceptible for failure. Now, this is a reminder of the reality that earthquakes in and of themselves does not have to be significant in terms of its magnitude for us to be experiencing the reality of hazards in a form of landslips, to say the least. Landslips, when you think about it, is more than likely also being triggered as a result of the seismic activity that the active faults are actually inherently yielding. So if we know where the active faults are, if we know also where the faults are, it gives us a better picture in terms of understanding what is the slope strength or the slope weakness in that respect, and in so doing help us towards mitigating the whole reality of landslides and the inconvenience of landslides. So as an example, through, let's just say, roadblocks and or the hazardous nature of landslides in terms of, us being in a situation where our houses may slip, or it being a case where our houses are at risk of experiencing debris falling into, our overall properties. This is why mapping is important. This is why obviously knowing what is the active fault nature around the overall landscape, around our properties, are important, and this is why we have to also be consistently monitoring what exactly is transpiring geodetically, seismically, or seismologically, as well as what is also transpiring in terms of what we see with our eyes, geologically and even geographically.